When people hear the word dopamine, it's usually in the context of pleasure, of feeling good. Popular narratives often depict dopamine as the molecule that makes us feel rewarded, satisfied, or happy. And while dopamine is involved in those things, that view is incomplete. In fact, it's one of the most important things to understand if you want to truly harness motivation and develop sustained drive. What dopamine actually does more than anything else is modulate our sense of motivation and pursuit. It governs what we pay attention to, what we're willing to work for, and how much effort we're willing to exert. Dopamine is not the molecule of pleasure. Dopamine is the molecule of desire. It's the molecule that motivates you to act in the direction of a goal. It's what gives you the feeling of wanting something, and it's that wanting, not the having, that is primarily dopaminergic. When dopamine levels rise in the brain, especially in key circuits such as the mesolimbic pathway, what you're experiencing is an increase in motivation. You're not necessarily feeling pleasure, you're feeling energized, directed, and focused toward a target or outcome. This is critically important because it reshapes how we understand drive. Most people wait until they feel good to start working toward their goals. They think, when I'm in the right mood, I'll go to the gym, or once I feel ready, I'll start that project. But the neuroscience tells us that the very act of anticipating a reward is what generates the dopamine needed to begin. That anticipation is neurochemically reinforcing. It sets off the dopamine response that mobilizes energy in your body and mind. Let's talk about what that looks like at the level of neurobiology. Dopamine is synthesized in a few key areas of the brain, most notably the substantia nigra and the ventral tegmental area (VTA). These areas send dopamine projections into parts of the brain like the nucleus accumbens, the prefrontal cortex, and the striatum. These are regions that regulate things like decision making, motor output, and value estimation. What this means is that dopamine doesn't just make you feel good, it actually biases your cognitive and behavioral systems toward action. Imagine a mouse in a lab. If you stimulate its dopamine system in anticipation of a reward, it will press a lever repeatedly, even if the reward is delayed. But if you eliminate that anticipatory dopamine signal, the mouse loses motivation entirely, even if the food is right in front of it. This isn't just animal behavior, humans show the same phenomenon. When dopamine levels are disrupted, our drive to engage with life, to pursue learning, fitness, relationships, or achievement starts to decay. Now, it's also worth noting that dopamine works as a teaching signal. It helps you learn what's worth pursuing again. When your brain experiences a positive prediction error, in other words, when you get more than you expected, dopamine surges. That surge tells your brain, this was better than expected, do it again. Conversely, if you get less than expected, a negative prediction error, dopamine levels drop, and your brain notes that something about the pursuit wasn't quite right. So dopamine doesn't just drive motivation, it shapes learning. It refines our understanding of what kinds of behaviors are worth investing in, which is why it's so important that we don't just use dopamine-stimulating activities randomly. If your brain starts learning that passive activities like scrolling social media provide big dopamine spikes, it will shift your motivation circuitry toward those behaviors. Over time, you'll feel less inclined to pursue challenging goals because your brain has learned that easy rewards are good enough. This leads us to another key point. Dopamine is relative. The brain tracks baseline levels of dopamine and detects spikes relative to that baseline. The more frequently you experience big dopamine spikes, the more your baseline drops. And the lower your baseline, the harder it becomes to feel motivated for anything, especially if the thing you're pursuing doesn't offer an immediate or intense dopamine surge. This is part of what's behind the modern epidemic of low motivation and attention fatigue. We live in an environment saturated with high dopamine stimuli, likes, notifications, entertainment on demand. These cause intense dopamine spikes without any effort. Over time, This trains the brain to expect high dopamine with low effort, and it lowers your capacity to engage in sustained pursuit. You can't get yourself to read, to work out, or to concentrate because the effort required doesn't match the artificially inflated reward expectations your brain has come to rely on. To make this practical, one of the most powerful things you can do to build long-term motivation is to reconnect dopamine to effort and pursuit rather than outcome. If you start telling yourself, "This workout is hard, but the effort is the win," you begin to condition your brain to release dopamine from the process itself. You're literally rewiring your reward system to reinforce hard work instead of just results. This has been shown in studies on growth mindset and intrinsic motivation. When people are rewarded for effort, not just outcome, they become more persistent and resilient. They bounce back faster and they enjoy the process more. This is why learning to delay gratification and lean into discomfort is so neurologically powerful. You're not just building character, you're recalibrating your dopamine system. You're teaching your brain that effort and challenge are predictive of long-term rewards. This keeps your baseline dopamine levels healthier and makes you less dependent on short-term stimuli to feel driven. It's also worth mentioning that dopamine doesn't act alone. It interacts with other neuromodulators like norepinephrine, which governs alertness, serotonin, which regulates mood and satiety, and acetylcholine, which supports focus and learning. But dopamine is what gets the system moving. Without dopamine, there is no direction. There is no sense of this is worth doing. That's why in conditions like Parkinson's disease, where dopamine neurons in the substantia nigra degenerate, patients often experience not only motor difficulties, but also profound drops in motivation and energy. The system that says move toward this goal is broken. So how can we take all this and apply it in a meaningful way? First, we need to stop thinking of dopamine as a passive pleasure molecule and start viewing it as an investment signal. Your brain is constantly asking, where should I invest my energy? What's worth moving toward? Dopamine answers that question. The activities you repeatedly engage in and derive anticipation from are training your brain's investment strategy. If you want to be more driven, more consistent, and more focused, start paying attention to what's triggering your dopamine and whether those triggers are aligned with your long-term values. If you're getting big dopamine surges from things that don't require effort, you're weakening the motivational circuits that support sustained pursuit. On the other hand, if you can teach yourself to anticipate dopamine from effortful action, if you can fall in love with the chase, not just the catch, you will have access to an almost inexhaustible reservoir of drive. That's not philosophical advice, it's neuroscience. The mesolimbic dopamine system is plastic. It adapts, and every day, every action, every choice is training it. You are either conditioning yourself to rely on external, easy dopamine hits, or you're investing in internal systems of motivation built around challenge, curiosity, and meaningful goals. To summarize, the key to understanding dopamine is recognizing its role in the anticipation of reward, not just the receipt. This anticipation fuels energy, effort, and attention. When we learn to control that system not by overloading it, but by carefully managing it, we become architects of our own motivation. That's the foundation of a motivated brain, not chasing pleasure, but investing in the pursuit itself. And once you learn how to do that, once you understand that the real neurochemical gold isn't at the finish line, but in the striving itself, you'll no longer need to wait for motivation to show up. You'll know how to create it on demand through focused action and purposeful effort. That's dopamine properly understood. And that's how you build real, lasting drive. Dopamine is often thought of as something infinite, a renewable emotional spark we can just summon on command. But this is a misrepresentation of how the brain actually works. Dopamine, like energy or attention, is a limited resource. Not in the sense that you'll run out permanently, but in the sense that how and when you use it deeply affects your ability to regulate motivation over time. The truth is, dopamine functions like a form of internal currency. And just like any currency, if you spend it recklessly, you devalue its power and diminish your purchasing strength in the future. If you invest it wisely, by choosing the right sources of reward and spacing them out strategically, you amplify its effectiveness and protect the vitality of your motivational system. Inside the brain, dopamine operates on two fundamental axes: baseline levels and phasic spikes. Baseline dopamine is your resting level willingness to amount of dopamine, e.g. circulating and being released in key brain regions like the striatum and prefrontal cortex in the absence of direct stimuli. Then there are phasic spikes, brief, rapid increases in dopamine triggered by specific events, behaviors, or thoughts. These spikes are the moments when you feel heightened desire, motivation, or drive. Importantly, these phasic increases are what allow us to feel momentum toward goals. They energize behavior and signal the brain that something important is happening, something worth acting on. However, when these spikes occur too frequently or too intensely, especially in response to behaviors that require very little effort, something damaging happens. The baseline dopamine levels begin to drop. This phenomenon is known as dopamine depletion. But it's less about running out of dopamine in a literal sense and more about the brain adapting to high levels of stimulation by downregulating the system. In neuroscience, we refer to this as receptor downregulation and adaptation. When dopamine receptors are repeatedly stimulated, especially in a context of low effort, the brain becomes less responsive to the same stimuli over time. This is exactly what we observe with addiction, not just to substances like cocaine or amphetamines, but to behaviors like binge, watching content, scrolling on social media, or constant gaming. The danger isn't just that these behaviors give you pleasure. The real danger is that they provide disproportionately high dopamine returns with minimal investment of effort. Think of it this way: if you can sit still and scroll a screen for 30 minutes and experience hundreds of novelty-based dopamine spikes, likes, videos, highlights, your brain starts recalibrating its sense of value. It begins to interpret effortless stimulation as normal. Consequently, the much smaller dopamine increases associated with delayed, effortful goals such as studying, building a skill, or working on a relationship start to feel unrewarding. You lose motivation not because your goals have changed, but because the chemical signal that once told your brain this is worth it has become dulled through overexposure. This is the neurobiological equivalent of inflation. If your brain is exposed to constant high dopamine rewards without effort, the currency of dopamine becomes inflated. The value of each reward becomes smaller, and it takes more and more stimulation to achieve the same effect. This is why people who engage in high-frequency, low-effort dopamine activities often report feeling chronically unmotivated, distracted, and emotionally flat when they try to return to baseline tasks. The real problem isn't with the tasks. They just feel underwhelming in comparison to the hyper-stimulating environments their dopamine systems have adapted to. To correct this imbalance, we must begin thinking of dopamine as a finite investment resource. You can't just spike your dopamine repeatedly and expect to stay motivated. Instead, you need to become strategic, reserving your dopamine spikes for behaviors that align with your long-term goals. That means understanding the concept of dopamine spacing, creating intentional gaps between high-reward experiences to allow your baseline to return to equilibrium. This concept has been observed in studies on addiction recovery, behavioral reinforcement, and even productivity routines in high performers. Spacing dopamine allows the system to reset. When you abstain temporarily from highly stimulating activities, your dopamine receptors become more sensitive, your baseline begins to rise again, and smaller actions become rewarding. In practical terms, this is why people who do intermittent fasting of behavior, such as digital detoxes, cold exposure, or deliberate rest days, often report renewed clarity, focus, and drive. The brain recalibrates, and the same activities that once felt mundane start to feel meaningful again. You're not changing the activity, you're changing your dopamine context. There's also the issue of randomness and variability. The dopamine system thrives on unpredictability. One of the strongest triggers of dopamine release is the concept of intermittent rewards that are not always guaranteed, and that come unexpectedly. This is the same mechanism that keeps people pulling the lever on slot machines. The uncertain timing of the reward makes the pursuit feel more rewarding than the reward itself. This concept, called the dopamine prediction error, means that when a reward is larger or arrives unexpectedly, the dopamine spike is much greater than when it is predictable or guaranteed. You can use this to your advantage by varying the size and frequency of your own rewards, especially for effort-based tasks. You teach your brain to value pursuit and unpredictability again. Let's say you're writing a book, and every time you finish a page, you reward yourself, but sometimes with something small like a stretch or walk, and occasionally with something larger like a night out or a personal treat. That variable reward schedule triggers more consistent dopamine activation than a predictable reward would. The variability makes your effort feel more engaging, and you stay motivated longer. It's also critical to note the distinction between exogenous and endogenous sources of dopamine. Exogenous stimuli are those that come from outside your body, like drugs, social media, sugary foods, or external praise. These can hijack the dopamine system because they create large spikes without any requirement for effort. Endogenous dopamine, on the other hand, is generated through your own internal processes through deliberate action, effort, learning, or challenge. These are the kinds of dopamine sources that build resilience, mental toughness, and long-term drive. When you perform a hard workout, finish a difficult task, or push through discomfort to achieve a goal, your brain releases dopamine in a way that strengthens the circuits of discipline and motivation. The mistake many people make is trying to artificially supplement low motivation by introducing more exogenous stimuli, energy drinks, instant entertainment, or constant novelty. But the solution isn't to add more dopamine. It's to protect the natural system by reducing unnecessary stimulation and investing attention in meaningful effort. This is what it means to invest dopamine like currency. Just like in finance, real wealth isn't created through reckless spending. It's created through disciplined, long-term investment. In this case, that investment is your attention and energy toward goals that matter, pursued with deliberate effort and strategic reward. You can think of each day as having a finite budget of dopamine attention. If you spend it all in the morning on meaningless tasks or passive consumption, you're less likely to feel energized for the work that actually moves your life forward. But if you conserve that budget and allocate it intentionally to tasks that involve challenge, learning, or creativity, you start to build an internal loop where effort becomes energizing. To do this effectively, many high performers adopt protocols of delayed gratification, dopamine fasting, and non-rewarding effort. For example, working in distraction, free environments without music, notifications, or constant feedback helps the brain reattach dopamine to the task itself, not the surrounding stimuli. Similarly, practicing routines like cold exposure, intense exercise, or fasting teaches the brain to release dopamine in response to physical stress, another way of investing effort for long-term motivational gain. It's important to understand that none of this means eliminating pleasure or avoiding fun. What it means is protecting the contingency between effort and reward. If you want to feel real satisfaction and purpose, your brain has to believe that rewards are earned, not given freely. That contingency is what makes dopamine reinforcing, and it's what keeps you moving forward with purpose instead of bouncing between meaningless distractions. Ultimately, managing dopamine like a finite resource requires awareness, strategy, and discipline. It means asking yourself regularly, is this behavior reinforcing effort or bypassing it? Am I rewarding myself for pursuit or just chasing novelty? Am I spacing my dopamine spikes in a way that protects my baseline? When you start asking these questions, you begin reclaiming control of your motivation system, not just through willpower, but through biology. And the reward for this kind of self-regulation is enormous. When you learn to direct your dopamine system wisely, you begin to experience effort as meaningful, challenge as energizing, and work as inherently rewarding. This isn't about becoming less emotional or more robotic. On the contrary, it's about becoming more human, more capable of sustained purpose, focused energy, and deep engagement. That's the essence of true motivation. And it begins by respecting dopamine for what it is, not a toy, not a trick, but a powerful resource that can either enslave you to instant gratification or empower you to build the life you truly want. One of the most transformative things we've learned in neuroscience over the last couple of decades is that the brain is not hardwired to only release dopamine upon achieving a goal. In fact, the human brain can be trained, literally rewired, to release dopamine in response to the effort made during the pursuit of a goal, independent of the outcome. This insight overturns a deeply ingrained misconception, which is that motivation is something we feel after success. That dopamine surges come only as a reward, a kind of biochemical prize for crossing the finish line. The reality is quite different, and when understood properly, it can completely shift how someone approaches work, persistence, learning, and overall life satisfaction. There are a number of ways, practical evidence-based methods, to increase dopamine in a responsible and sustainable way that supports long-term motivation and drive. These methods aren't about tricks or shortcuts. They are grounded in solid neuroscience and aimed at enhancing the brain's natural dopamine system without overloading it. The key idea here is to stop thinking of dopamine as something to hack and start thinking of it as something to optimize, just like you would optimize sleep, nutrition, or physical training. And just like any system in the body, the dopamine system requires balance, timing, and thoughtful engagement in order to function properly over time. One of the most effective and accessible ways to increase dopamine sustainably is through goal setting. But not just setting any goals, setting goals that are incremental, achievable, and aligned with a larger vision. The human brain is uniquely tuned to the pursuit of goals. Each time we move even slightly closer to an outcome we value, dopamine is released. This is sometimes called the dopamine drip, and it acts as a form of progress signaling to the brain. What's crucial is the structure of those goals. If your goals are too vague or too distant, you won't get the steady dopamine feedback that helps maintain effort. If they're too easy, the brain won't register progress as meaningful. The ideal structure is what's called layered reward architecture, having a long-term goal supported by short-term, behaviorally linked milestones that provide clear evidence of progress. Take, for example, someone training for a marathon. The final event may be months away, but if the training plan includes daily runs with specific targets, such as distance, speed, or form, then every successful training session becomes a dopamine-boosting event. The brain learns to value the process, not just the end point. This form of progressive effort feedback loop has been shown to increase dopamine tone in the striatum and prefrontal cortex, areas essential for persistence and executive function. What you're doing is teaching your brain to find reward in consistency, which is arguably one of the most powerful motivational advantages a person can have. Another tool is cold exposure. When used correctly, cold exposure, such as cold showers or ice baths, can result in a significant and long-lasting increase in dopamine levels. One peer-reviewed study showed that a single bout of cold water immersion at around 14 degrees C for several minutes could increase dopamine by up to 250%, and that elevated state can last for hours. What makes this particularly interesting is that it's not tied to pleasure in the conventional sense. Most people don't enjoy the cold. What's happening instead is a powerful activation of the sympathetic nervous system, which increases alertness and causes a surge in catecholamines, including dopamine. The real utility of cold exposure lies in its combination of discomfort and reward. Because cold exposure is voluntarily undertaken and mentally challenging, the brain learns to associate effort with dopamine release. Over time, this strengthens the circuit linking resilience and reward. That's crucial because it makes you less dependent on external ease or comfort to feel motivated. You're training your nervous system to seek out challenge, not avoid it. This builds what we refer to as dopaminergic resiliency, the capacity to generate motivation from difficult, even unpleasant, stimuli. Sleep is another major factor. Sleep is not just rest. It is the time when many of the systems that support dopamine production and receptor sensitivity are reset. Poor sleep quality or chronic sleep deprivation directly impairs dopamine receptor availability in key brain regions such as the striatum. This is why people who are sleep deprived often report a lack of motivation, focus, and drive. Even if dopamine is being produced, if the receptors aren't functioning properly, the signal can't be processed. So if you're trying to optimize motivation, you absolutely must prioritize deep, consistent, high-quality sleep. Particularly the first few hours of the night, which include the largest proportion of slow, wave sleep responsible for restoring neurotransmitter balance. Sunlight exposure is another foundational practice that boosts dopamine in a more indirect, but equally essential way. Early morning sunlight, in particular, helps regulate the circadian rhythm, which governs the timing of dopamine release and other neurochemicals throughout the day. When you get sunlight in your eyes within the first 60 minutes of waking, especially for 10 to 15 minutes outdoors, it sets off a cascade of photoreceptive and hormonal events that increase cortisol in the morning, which is good in this context, increase alertness, and help dopamine release occur at the right time throughout the day. It also leads to improved dopamine receptor expression. Natural light exposure has been shown to increase tyrosine hydroxylase activity, the rate-limiting enzyme in dopamine synthesis. What this means functionally is that by getting sunlight early, you're telling your brain, it's time to be alert, it's time to focus, and it's time to get moving. That alignment of light and internal chemistry is a key driver of motivation. Another dopamine supporting tool is physical exercise. Almost any form of aerobic or resistance-based exercise, when done regularly, results in significant increases in dopamine production and receptor density. It's particularly effective when the activity is perceived as moderately challenging but enjoyable. But beyond the biochemical effects, what matters most is consistency. Movement generates more dopamine when it's attached to deliberate effort, particularly effort that's associated with self-improvement or skill development. Learning a new movement pattern, increasing strength, or improving cardiovascular capacity all send a very strong dopaminergic signal to the brain, saying, this behavior leads to progress. And once the brain registers progress, it wants to do it again. That's the feedback loop of motivation being built. It's important here to understand that the most powerful dopamine-driven behaviors are not built on dopamine peaks, but on steady, well-timed waves. The biggest mistake people make is seeking out sharp, repeated dopamine spikes, whether through junk food, social media, or compulsive novelty. These high peaks, when not balanced with baseline recovery, lead to what's known as dopamine burnout. This is where even moderately pleasurable tasks begin to feel dull and motivation flatlines. The key is to avoid constant high-frequency dopamine stimulation. That means spacing out rewards, delaying gratification, and sometimes choosing effort even when there's no immediate payoff. The use of deliberate non-reward periods is another effective method. These are intervals where you deliberately avoid stimulation or reward, even after effortful behavior. For example, finishing a task and simply taking a quiet walk instead of jumping into entertainment. This helps reinforce the association between effort and internal satisfaction rather than external stimulation. It trains the nervous system to find a baseline of pleasure in calm, focused states, rather than needing continuous hits of novelty or reward. You can also use what's called NANS, deep rest NSDR, which includes protocols like yoga nidra or body scan meditations. These practices allow the mind and body to reset without full sleep, and have been shown to increase dopamine receptor sensitivity. When practiced regularly, ideally in the middle of the day, they enhance recovery, regulate the autonomic nervous system, and increase your capacity to focus and engage deeply in future tasks. These tools are excellent ways to manage dopamine recovery, which is a vital part of investing in this neurochemical wisely. From a dietary standpoint, ensuring adequate intake of precursors like tyrosine, an amino acid found in protein-rich foods, is also essential. Tyrosine is converted into L-dopa, which then becomes dopamine. Foods such as eggs, poultry, beef, nuts, seeds, and certain legumes can support this pathway. But just consuming these foods isn't enough. The body also needs key cofactors such as iron, vitamin B6, and magnesium to complete the conversion. Without proper nutrition, the dopamine system cannot be maintained, even if all the behavioral tools are in place. There's also emerging evidence around psychological practices like gratitude and visualization. While these may seem abstract compared to the neurochemical precision of cold exposure or exercise, they activate many of the same reward pathways. When individuals visualize progress or mentally rehearse successful outcomes, areas of the brain involved in motivation and planning, such as the ventromedial prefrontal cortex, show increased activity. These practices also shift dopamine release toward the belief in success, not just the experience of it. And that belief creates what's called anticipatory dopamine signaling, which can lead to increased willingness to take action. The takeaway here is that investing in your dopamine system means building habits and environments that reinforce long-term drive. It's not about short-term excitement or temporary motivation boosts. It's about building a neurological infrastructure that favors resilience, effort, and consistent pursuit of goals. This requires engaging with discomfort, cold, effort, challenge, and strategically placing rewards where they support motivation rather than disrupt it. When people misuse dopamine by constantly seeking the next hit, the next novelty, the next easy thrill, they damage their ability to experience deep focus, long-term effort, and intrinsic satisfaction. But when people respect dopamine as a biological tool and use the methods supported by science, goal structuring, cold exposure, light, exercise, nutrition, strategic rest, they build a system that is not only sustainable but self-reinforcing. They build a brain that wants to do hard things, not because it's forced to, but because it feels good to try. That's what healthy, motivated brains do. They don't wait for reward. They generate it from within. We now know that dopamine can be conditioned to release during goal pursuit, during the moments when no rewards are guaranteed. This ability isn't just a curiosity of the brain, it's a feature that we can deliberately cultivate. When you learn to derive pleasure, energy, and motivation not from the achievement itself, but from the process, from the steps, the strain, the uncertainty, you effectively become neurologically bulletproof. Why? Because you're no longer relying on external validation or a final result to drive your behavior. You've internalized the reward system, you've brought it into the moment of action, and that gives you access to a much more sustainable and resilient kind of motivation. Let's look at what's actually happening inside the brain. Dopamine is produced in several regions, notably the ventral tegmental area (VTA), and it projects to areas like the nucleus accumbens and the dorsal striatum. These areas are involved in both motivation and action selection. When dopamine is released, it changes the likelihood that a particular behavior will be initiated or sustained. So when you train your brain to release dopamine from the effort itself, you're enhancing the neural circuits that promote forward motion, persistence, and engagement regardless of the final outcome. To understand this more deeply, we can look at research involving both animals and humans. For example, in rodent studies, when animals are given the choice between a small reward with no effort or a larger reward that requires climbing a barrier or pressing a lever multiple times, the dopamine system determines their decision. If the dopamine system is functioning normally, they'll often choose the harder task to earn the larger reward. But when dopamine signaling is suppressed, they choose the easier option every time, even if it means getting less. Now, here's the critical part. If you modify the context in which the animal performs the task, you can shift the timing of dopamine release. If the animal begins to associate the act of pressing the lever or climbing the wall with a dopamine release, not just the reward afterward, it will perform the task more consistently and with greater vigor. The reward becomes the effort. Human behavior follows the same principles. When we focus exclusively on outcomes, external markers like money, recognition, or finishing a project, we make our dopamine release dependent on something that is both delayed and often outside of our control. That's a dangerous strategy. It makes us more vulnerable to disappointment, burnout, and disinterest. We begin to delay gratification so much that the brain stops associating our effort with anything positive at all. The system starts to degrade. But if we instead attach meaning and anticipation to the action itself, to the challenge, the discomfort, the training, the repetition, we start triggering dopamine internally, and we reinforce neural circuits that support consistency and drive. This can be developed through a practice called cognitive reframing, which is essentially a top-down process where the prefrontal cortex interprets a situation differently and signals other brain areas accordingly. For example, when you're working late on a complex problem and you consciously say to yourself, "This is hard and that's good. This is the moment that growth happens." You're reframing effort as valuable. That sends a signal to the mesolimbic system to release dopamine, not despite the discomfort, but because of it. Over time, this reshapes the brain's response to challenge. What was once experienced as a burden becomes a source of energy. There's strong support for this in studies on growth mindset and intrinsic motivation. Individuals who are praised for their effort rather than their intelligence tend to persevere longer and perform better in the long run. The reason is neurochemical. Their brains are learning that trying hard is itself rewarding. That sense of progress becomes the dopamine trigger, and it builds the habit of sustained motivation. This is not just psychological, it's structural. The repeated pairing of effort with dopamine reinforces the synaptic pathways that make effort more likely in the future. That's Hebbian plasticity in action, neurons that fire together, wire together. You can take this a step further with specific protocols. One powerful technique is what we might call effort-focused self-rewarding. When you're doing something difficult, working out, studying, coding, even having a hard conversation, you can consciously tell yourself something like, "This is the moment that counts. The fact that I'm doing this now despite it being hard is what makes me better." That internal dialogue, repeated consistently, starts to act as a cue for dopamine release. The brain begins to interpret effort as reward, predictive, and it adapts. It learns that trying is worth doing, even without a guarantee of success. Another key concept here is what's called reward prediction error. This is the difference between expected and actual outcomes. When we get more than we anticipated, dopamine spikes. When we get less, dopamine drops. But here's the nuance. You can shift this system by adjusting what you expect. If you train your mind to expect nothing but growth from every effort, no external success required, you'll experience more positive prediction errors. Each small win or unexpected insight becomes a dopamine trigger. You're not just waiting for a finish line. You're rewarding yourself at every mile marker, and that keeps the system energized. Contrast this with the common approach where dopamine is postponed until results appear. That model often leads to a crash. The person works hard, expecting a surge of satisfaction at the end. But when that reward is delayed, or worse, when it falls short of expectations, the brain experiences a dopamine drop. Motivation tanks. The system associates effort with frustration. Over time, this leads to procrastination, avoidance, and even depressive symptoms, not because the person is weak or lazy, but because their reward system has been conditioned to disengage from process. There's another important layer to this, and that's the temporal dynamics of dopamine. When dopamine is released during effort, it doesn't just feel good in the moment. It also prepares the system for future action. It sets up a positive feedback loop in which effort leads to motivation, which leads to more effort. This is critical in habit formation. Every time you reinforce the link between effort and internal reward, you're strengthening the striatal pathways responsible for action repetition. That's how routines become effortless, not through willpower alone, but through, calibrated dopamine release during effortful behavior. Interestingly, this same mechanism is at work in elite performers across all domains: athletes, musicians, scientists, entrepreneurs. These individuals often report experiencing satisfaction not just in success but in the grind itself. And while that might sound like a personality trait, the neuroscience suggests it's a trainable state. Their brains have learned to associate the stress of practice, the uncertainty of experimentation, and the tension of competition with the release of dopamine. That association reinforces their engagement and fuels their long-term drive. You don't have to be born with that mindset. You can cultivate it, and you start by becoming conscious of the narrative you attach to effort. Is it something to be endured until the reward arrives? Or is it something to be embraced as its own kind of reward? The answer to that question determines the architecture of your motivation system. It determines whether your drive is dependent on outcomes or generated from within. This is especially relevant in a world where instant gratification is everywhere. When everything is optimized for convenience and comfort, the brain becomes less tolerant of effort and less capable of sustaining motivation. But if you reclaim effort as a source of dopamine, you become adaptive. You become someone who seeks challenge, not because it's easy, but because you've trained your nervous system to respond positively to it. That's a major shift. It's what separates reactive behavior from proactive pursuit. So the next time you find yourself deep in a task that feels draining, consider this. The moment you push through, the moment you stretch your limits, you have an opportunity to teach your brain that effort is valuable. And if you do that repeatedly, with awareness and intentionality, you'll change the structure and chemistry of your motivation circuits. You'll become someone who doesn't need to wait for motivation, because you've built a system where effort is intrinsically rewarding.